In this lesson, we're going to learn about the law of sines and the law of cosines. These two rules are going to go ahead and make sure that you can do lots of different applications with your trigonometry. The law of cosines is actually an expansion of the Pythagorean theorem. In this lesson, you will learn to solve any triangle, not just right triangles. In order to do so, you'll need to calculate trigonometric ratios for angle measures up to 180 degrees. You can use a calculator to find these values. Use your calculator to find each of the trigonometric ratios. Round it to the nearest hundredth. So go ahead and try that and then double check your answers with the computer. You should have gotten tangent of 103 approximately negative 4.33, cosine of 165 approximately negative 0.97, and sine of 93 degrees approximately 1. Our first example is going to use a calculator to find each of the trigonometric ratios here and round to the nearest hundredth. So try these ones just to make sure that you don't have any problems with your calculator and double check them. If you aren't getting the right answers, make sure your calculator is in degree mode, not radian mode. You can use the altitude of a triangle to find a relationship between the triangle's side lengths. In triangle ABC, let h represent the length of the altitude from C to the line AB. From the diagram, sine of A is equal to h over b, and sine of b is equal to h over a. By solving for h, you find that h is equal to b sine a, and h is equal to a sine b. So b sine a equals a sine b, and sine of a over a equals sine of b over b. This is the law of sines. You can also use another altitude to show that the ratios are also equal to sine c over c. I always thought this was one of the easiest things to remember just because all the letters match up with each other. So for any triangle ABC with side lengths A, B, and C, sine A divided by A equals sine B divided by B, which is equal to sine C divided by C. So you can use any of these proportions in conjunction with each other to find missing angles or missing sides depending on what you've been given. You can use the law of sines to solve a triangle if you're given either A, two angle measures in any side length, or B, two side lengths in a non-included angle measure. Let's look at an example. We want to find the measure of FG. We've been given two angles, F and H. So if we use the law of sines, sine of F over GH, because GH is the opposite side, equals sine H over FG. Plugging in, we get that sine of 39, which is angle F, over 40 equals sine of 32, which is angle H over FG. Cross multiply and divide by sine 39. Go ahead and plug that whole mess in your calculator. Just make sure that after the number 32, you close your parentheses, otherwise you'll get a completely different answer. So make sure that you have put parentheses around all of your degree measurements and then press enter, and you should get approximately 33.7. If you don't, double check your calculator entry, and if there's any problems you can show it to me in class and I'll see if I can figure out what you did wrong. Now let's try to find an angle measure. Here we're trying to find the measure of angle Q. So we set up the law of sines, sine of P over QR, which is the opposite side, equals sine Q over its opposite side, which is PR. We plug in the values we know. Sine of 51, which is angle P, over 8 equals sine Q over 6. Multiply both sides by 6 so that you have this expression. Put it in your calculator, and this time you have to use one more button because we have to do the inverse of that whole mess. So we have to do the inverse sine of whatever answer you get for the expression above. So when you put all of that in, you should get approximately 36 degrees when you round it to the nearest degree. Remember, make sure that you do not round until the very end. So if once you get an answer in your calculator, use that for the next step. Use your answer button. The law of sines cannot be used to solve every triangle. If you know two side lengths in the included angle measure, or if you know all three side lengths, you can't use the law of sines. Instead, you need to apply the law of cosines. The law of cosines is extremely similar to the Pythagorean theorem. In fact, it is the Pythagorean theorem. It's just a more general version that can be used for many triangles, not just right triangles. For any triangle ABC with side lengths A, B, and C, a squared equals b squared plus c squared minus 2bc cosine A. B squared equals a squared plus c squared minus 2ac cosine B. Or c squared equals a squared plus b squared minus 2ab cosine C. The way I always remembered it was, I know that's a lot of information to remember, the way I always remembered it was one side equals the other two sides squared minus twice those two sides and the cosine of the angle from the original side that we have on the other side. So if you have a squared by itself, the cosine is of a. If you have b squared by itself, it's the cosine of b. If you have c squared by itself, it's the cosine of c. Other than that, you use the two sides that are not included for the rest of the equation. You can use the law of cosines to solve a triangle if a, you're given two side lengths and the included angle, or three side lengths. The angle referenced in the law of cosines is across the equal sign from its side, like I said. Now we have the line xz is what we're trying to find here. So we use the law of cosines. We say xz squared equals xy squared plus yz squared, so that's all three sides, minus twice xy yz times cosine of y, because y is opposite xz, which is on the other side of the equal sign. We substitute in all of the given values. So we get 35 squared plus 30 squared minus 2 times 35 times 30 cosine of 110. You can go ahead and put that gigantic mess in your calculator. Just make sure that you are the entire part at the end is put together. Don't do 35 squared plus 30 squared minus 2 and then start multiplying things. You need to make sure that that last part is all multiplied before you subtract it. So if you go ahead and simplify this, you should get xz squared approximately 2843.2423, and then take the square root, which should give you xz equal to approximately 53.3 units. Here we want to find the measure of angle t. So we have three sides and we need to find the angle. So here we have rs squared equals rt squared plus st squared minus 2rt st cosine t. When we substitute, we get everything except for angle t. So we have to take 7 squared plus 13 squared plus 11 squared minus 2 times 13 times 11 cosine t. The most common mistake here is to take 290 minus 286 and then divide that to the other side. In order to do the steps properly, you have to subtract 290 from both sides and then divide by negative 286. You can't put those together until the end. Now that we divide by that, we get cosine of t equals 241 over 286. You need to use your inverse button on your computer, or calculator rather, in order to find what your angle is equal to. So when you plug that into your calculator, you use your inverse cosine button, you should get approximately 33 degrees for the measure of angle t. Do not round your answer until the final step of the computation. I know we've told you this probably 6 times by now, but that's very important. Because cosines are only between 0 and 1, rounding them can make a huge difference. So we want to make sure that we're using the most exact answers that we possibly can. Here's an application with a sailing problem. A sailing club has planned a triangular race course as shown in the diagram. How long is the leg of the race along BC? How many degrees must competitors turn at point C? Round the length of the nearest to the nearest tenth and the angle to the nearest degree. So we have a side, and an included angle. We need to use law of cosines. So BC squared equals AB squared plus AC squared minus 2AB AC cosine A. We substitute all the values we know and plug that all into our calculator to find that BC squared is approximately 7.7222. Taking the square root of both sides, we find that BC is approximately 2.8 miles. Now we can find the measure of the angle through which the competitors must turn. This is the measure of angle C. For this, you can use the law of sines and substitute the values that we know. We know sine of 45 is opposite 2.7789, and sine C, which we don't know what angle C is, but we know that angle C is opposite 3.9. We multiply both sides by 3.9, plug that into our calculator, and find that our angle is equal to approximately 83 degrees. Here's your lesson quiz. Practice these questions. I know that most of you are probably going to have questions on this tomorrow because this is one of the more difficult trig applications, and we'll be doing this for a couple of days. So if you're still a little shaky on it, don't panic. We'll go over it tomorrow and the next day. Just make sure that you've watched the video, you understand it the best you can for right now, and we'll just continue to work with it until you guys are comfortable.